All right, so the quick tutorial, hopefully it'll be a short video of how to narrow a VW Beetle adjustable beam. This is going to be for a link pin setup. You can tell by the square torsions there, but the same principle for ball joint. And first things first, we got to get the beam prepped. So that means cutting off the snubbers. We're going shockless, so I'll cut the top of the shock mounts off up here. Got to remove the frame mounts and steering dampener. And I think that's everything I got to get taken off this beam right now. All right, here we have it. Beam is blown apart. So, got the ends cut off right there. Got the shock towers cut off right there. Then we got the beam mounts cut off. We're going to reuse those. And then that's your steering dampener bracket that was back over here. Don't know if you're going to use that or not yet. We'll figure that out further down the road. I might just make something different. So, a lot of cleanup to do on the beam tubes. All I used was hammer, chisel, angle grinder, and that little sawzall. Use that little shorty blade, the little longer one. Didn't go into the side of the beam too much, so I didn't damage anything, which is always nice. And then these brackets, they still have their general shape left as far as curvature to the beam. So, first part of the sweat equity beam is done. Bring it back after I've got this all cleaned up. Okay, literally 10 minutes later, probably less, to be honest with you. Got all that stuff smoothed out. There are some divots, you know, from removing the brackets. If you are really worried about it, you can fill them back in with weld and grind them smooth. I doubt I'm going to do that. So to get this, used a angle grinder and then used a flap disc and just went to town. That's where the steering dampener was. Still not sure how I want to cap these, so I left them alone for now. That's the steering box little bracket tabs. I'm probably gonna have to remove those, but that's where we're at. So this is gonna be a 6-inch shockless beam, and the same applies for a 4-inch narrowed shockless beam. Leaf pack is still in there, so I pick up the adjusters tomorrow, and that's when I'll whack this center section out and bring everything together. Okay, so got my center beam adjuster, which we talked about in the last clip there. These are, I think, probably the better of the two options. There's one called an Avis adjuster, which you kind of slot out this little section right here. But I like this weld-in pipe style. So a couple things to look at a front beam when you are getting ready to narrow it. First things first is you want to look at the ends of your beam here. Now this is a perfect example on this needle bearing beam. If you look right there, that's where the needle bearing is, and that's where the actual beam itself is. Now, it's kind of tough to tell in this video, but this needle bearing sticks out just a little bit proud of the surface, where opposed to this top tube here, you can see that the needle bearing is sunk in just a little bit, and that's what you are going to need when you're measuring off of here, because this dimension is fairly critical, because this is where you're going to set your camber once you get your trailing arms in. So we can move on to this side. On the other, this bearing's completely gone, so I'm good here, but this bearing here sits a little bit proud for my liking, so I'm just going to knock it in just enough, and I'll bring you back here, and then I'll kind of show you. Actually, I can show you right now why it's a slight little issue. So we got the good one here, and you can see that this steel straight edge sits nice and flush, where on this one you can see that it's proud right there. You can see that it actually will rock, and it's not, it rocks and it bumps into the upper one right here. Now it's only like a millimeter or two, but you only have like 9 millimeters to play with total to get your alignment for your caster. So setting yourself up for success now will make a better handling car at the end. Okay, got the bearings, the needle bearings knocked in inside of the beam just a little bit, or if you got Bakelite, same principle applies. Now let's talk about the adjuster and the narrowing. So said I'm going a 6-inch narrowed beam, so we have to take 6 inches out of the whole total here. So it's 3 inches on each side. Now if you're using the Avis adjusters where you put a little slot here for the adjuster, you literally just move over 3 inches and each side and cut, and you're good to go. It's a real easy mistake to make. This piece of pipe is 2 inches, so you have to take the 2 inches and add that to your overall beam width. So in actuality, you're taking 8 inches out of this beam. So it's going to be 4 inches per side because you're filling it back in with this piece of 2-inch pipe. Now it may seem obvious, but it's a real easy mistake to make. And you thought yourself you were getting a 6 or a 4-inch narrow beam, and you end up with a 2 or a 4. So that's 2 inches there, plus the additional 3 inches on each side, for a total of 8 inches getting whacked out of this beam. I'll bring you back because I'm not going to try to do that on camera. All right, got everything marked out here for the beam narrowing. So we're going to start with the 2-inch adjuster right here. So hopefully you can maybe read this. So overall, end to end, from here to the other side for the beam, 34 inches. Center is 17, which is right there. The adjuster is 2 inches wide. We're accounting for that right here. We're narrowing a total of 6 inches. So from the edge of the adjuster, we're coming over 3 on each side. So that gives us a total of 6. So the overall width is going to be 28 total. That will be our new width. So starting from the end, we'll get our little ruler right here. We're going to come over. It's 13, and that's on each end from there to there. So 13 and 13 is 26, plus the 2 inches for the adjuster. That'll give you 28 total in width. In order to measure, I'm using this machinist right angle. If you don't have one, you don't need it. This is just, I have it, so I'm going to use it. But that's how I'm determining all of my measurement points. Again, we're messing with millimeters, so you don't have a lot of wiggle room. So that's where we're at. I'll figure out how I'm going to cut it. I've got a pretty gnarly pipe cutter that I'm going to try to use. And if that doesn't work, I'm going to grab the angle grinder and chop it that way. But I'll do that off camera because it's not very fun to watch, and I don't have a good phone holder. So anyway, I'll bring you back in a little bit. All right, let's bring you up to speed to where we're at now. Got the beam chopped apart, got the important parts cleaned up, which is the welding areas. I think you can kind of see that I beveled the edges to get a little bit better weld penetration, just like this. So you're gonna have to figure out a way to get the adjuster lined up with the beam. And the way I'm doing it is using these things called V blocks. So it's kind of tough to see, but there's a little V shape in there that's for round tubing. And I've got everything all clamped up together. And there's a better picture of the V. So it's all lined up. I got it as close as I could, and I still have a little bit of gap going on there, but that's just kind of what it is when you're freehanding stuff this way. The important part though, you take a straight edge, you put it right along there, and you see the diameter of the welded in adjuster is a little bit smaller. So there's a little bit of tilt right there, but you can see that it's a parallel line. And you do the same thing on this side. And we're lined up on the beam there. And then we're lined up nicely on the adjuster. It's all clamped into place here. I'm going to start with the lower adjuster. I've got it positioned with the adjuster down here. It's vertical, so that's gonna, I think, give me the lowest possible adjustment that I can get. That's, I don't know if you can kind of see the half moon shape. That's the last little bit sticking out, and it was sticking up at about, the adjuster stuck up, or the grub screw initially is about at that angle there. So I've already turned the beam lower because I'm planning on running this hammered super low. So hopefully that makes sense. And again, I'm just going to do the lower adjuster right now, tack it into place, and flip the beam around on the V-blocks and do the upper adjuster. All right, got the first half tacked up here, and I thought I'd walk you through a couple things that I probably didn't talk about. First thing is getting the beam super clean, and that means the beam ends and everything there. And the inside is going to be full of shitty ass grease, old gross shit. So you got to get that as clean as you possibly can. As you can see, there's a little bit of, that's rust in the bottom of the beam there. I've stuffed the ends with paper towels because as you get this hot, the grease that's still inside the beam tubes is going to come running out. So I'm going to leave the paper towels in there while I weld, and then I'll fish them out after the fact. That's just I wouldn't call it a pro tip, but that's just a way to get your welds a little cleaner. You see the tacks in there. It's up on the blocks right now, but when I finish weld it, I'm going to weld it at an angle like this. That way, as that grease melts, it's going to run towards the end of the beam this way and not contaminate my welds, because I have in the past welded up adjusters in a beam, had it coming out, and I've literally had little fireballs dripping out of the beam as the grease catches fire with the spark. So obviously that's going to give a terrible weld. Other thing is the position of the beam, the adjusters themselves. So that's my lower one, and that's going to be about parallel with the floor or with the ground, the pan, whatever. This one here, I canted even lower, that and that's the upper beam tube. I did that because, again, I'm going as low as I probably am, probably going stupid low on this car. And I'll be able to tune the suspension a little bit with the arms fighting against each other. It's kind of how Porsche 356s did back in the day. They only had one beam adjuster, and you would tighten up the adjuster against the other one to make to tension up the suspension. I'm assuming I'm going to have to do the same thing to make this thing ride and not scrape everywhere I go. The other thing that I might note is this weld right there. That's the factory weld on the adjuster. Isn't that pretty? So once I finish welding that, I'm going to come in and go over those welds and just get a little bit better penetration. That's just going to make me feel better than anything. All right.
All right. I'm nervous. I kind of fucked up in the...
Yeah, what's wrong with that? Nothing.
Yay.
Okay. Just do that other one.
I got it fixed right here?
Yeah.
Or the whole line?
If you can do the whole line, go for it. You don't have to go as wide on that bead, though.
Okay. Andy told me I wasn't going wide enough.
You're plenty wide.
All right. fucked up at the end again.
What's the screw up?
Don't look at that.
What's the screw up? Get your hand out of there. What's the screw up? There's nothing wrong with that at all.
That little.
Yeah.
Do not go. Don't look.
Wouldn't frame it.
I don't think I'm doing good.
What are you talking about? Sounds fine.
But this, I munched right here,
So what?
and that's not even.
So what?
God damn it.
So what? Okay, so we've got the first section welded in. We're already tacked all the way around, so the beam is quote unquote solid. Now we just finish welding it. So we've got these welded like this, and as you can see, we're at an angle. And this side is pretty warm. Controlled the heat fairly well, so it didn't transfer into this side, so I'm not concerned about grease melting down into the beam this way and contaminating the welds. So I'm very happy about that. I'm just gonna let this cool down a little bit more, maybe give it another 10 or 20 minutes, and then we'll finish welding this side all the way around. Again, let it cool down, and then we'll get over here.
All right, don't look. Nice.
Oh, damn.
How many fucking dry runs am I gonna do? Huh? All right, don't look. It's okay, but it's okay.
I think it'll stick. Okay, we got the beam welded together, but we don't have the mount welded on yet. So the trick I came up with, since I don't have a jig, is to go ahead and mock it up on the beetle itself. So it's mounted up there, mounted up here. Everything looks good. Okay, and then I'm going to show you how I measured it from side to side. I took these bolts here and I indexed them so they're as vertical as possible, because mounting to your frame, that's going to be your center point. So I did it on this side and this side over here. So that way we can take a measurement. So we can hold a straight edge. This is how you're going to do your camber on the front as well. You're going to take a straight edge and then your steel ruler here. So we come up there and I get 8 3/8 on this side. And now we're going to come to the other side, do the exact same thing, except switch hands and somehow make it look smooth. And we get 8 and a fat 3/16. So I'm going to call that good. And that's centered side to side against the chassis, against the pan. It's real important that you do that and don't measure on the body itself, because if you look at this body, there's a little crunch there. So that's killed your measurement. And if you did that, you look decent there. Then you come to this side and it's all mashed in right there. So if you were measuring off the body, you'd have a crooked measurement, and maybe it would look centered in the wheel well, but your beetle would travel down the road with its ass kicked out and you'd look like a dumb shit. So make sure you measure properly. Okay, so to pick up where we left off, now we've got the beam centered. We know it's centered, it's confirmed. These bolts are tightened down up here. So your beam is basically locked into place, it's positioned. So we're gonna go ahead and tack weld it to the frame head. And then once it's tacked, we'll take it back down and do the finish welding on the table. Quick warning about welding on your car. is make sure your battery and any electrical stuff is disconnected, especially like electronic ignitions and stuff, because it's a very small chance, but there's still a chance that you could fry them. So, word to the wise. Okay, there we go. Here is the beam finished, welded through these little caps on top right there. Nothing pretty, but that's not really what we're going for. It's all been cleaned up and scrubbed down, prepping it for paint. I will tape off the beam ends so nothing gets into those needle bearings. Also disassemble the adjuster assembly a little bit, just to not have paint and shit all over it. To clean them, this metal here where it's kind of rusty and greasy and gross, you can kind of see there's a solution drying there. I'm using this concrete metal prep. I think it said 3-to-1 for painting. Yeah, mixed it 3-to-1 in a little squirt bottle. Probably was more like 2-to-1, but anyway, wipe it on there, and it's currently drying. And I'll wipe it down, zap this with a little bit of metal etching primer, and then good old Rust-Oleum semi-gloss black. I'll bring you back for that in a minute. Okay, we are getting closer. So now that the beam is narrowed, we've got some primer on it, letting that dry in the sun. Let's talk about tie rods. Yeah, you thought we were done, but we still have one more very important mod to make to your steering system. So we've narrowed the beam 6 inches, so it would make sense that we have to narrow the tie rods an equal distance as well. So of course we're going to do that on the left and the right tie rod, the short and the long one we've got here. So we're going to take 3 inches out of each side. So I've already marked them there on the end. 3 there, 3 here. This guy has this funky little, what do we want to call it? I guess for lack of a better word, we can call it a chamfer, and that's where this jam nut is going to spin onto it to clamp down on it. You see, we've got these little slots here, so as this nut tightens down, it's going to squeeze on the threads to lock them down. I think the easiest way to do that is with a Dremel tool with a little abrasive disc, and you'll be able to cut those grooves. There's 1, 2, 3, 4 on there. So that would be at the, if you're staring at it on the end, be the 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock position is how I'm gonna cut those slots. This side, on the other hand, this is the long arm that has the jam nut assembly on this side, and on the other side is something that looks more like a old school bicycle seat clamp. And how this one works is there's a big fat groove in there, and the bolts goes through here. Now what you can't see, and I'll have to detail this a little bit later, is where that bolt is going through here. There's a divot carved out in the side of the tie rod, so the bolt actually clears the tie rod, and I think that probably helps it prevent this from spinning too while you're tightening it and whatnot. So now that we've narrowed it and we have these threads in here, how are we going to do that? Well, we bring you over to here, and this tap for the tie rods is an M14 by 1.5 RH, meaning right-handed, because we're not going to take 1.5 inches out of each half and get a right and a left-handed tap. We're just going to take it all from here out of one side. Saves you time, saves you money, because usually a left-handed tap is quite a bit more. Make sure you get a good one if you don't have one. I happen to have one, so it's It's made in USA, which that's usually a pretty good sign that it'll be all right. The drill is 12.5 millimeter for that tap. I don't have that on hand. The SAE equivalent is 0.491. The closest I have is 0.48 and change. So I don't think that little extra bit is going to be problematic. I also read that you could use a 1/2 inch drill bit. That's a 0.50, which we're messing with steering components. I'm not thrilled with that idea, but that's just me being a little bit extra. Clearly, with some of my work, I'm kind of, I'll let anything fly. But when it comes to steering components, probably should do the best you can. So I would go ahead and order the correct drill bit. I think I'm going to avoid doing the 0.5. So anyway, I'll bring you back and let you know how that works out for me. Okay, so I just gave you this big old speech about making sure that you have the right size drill and don't use the oversized one, use the correct one, blah, 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 blah. Chopped off the end of the tie rod. This is my drill bit that's slightly undersized. Oh, fuck yeah. So that one clears like a champ. This is the 1/2 inch one that I said not to use. Bam, doesn't go in. So let's see. Yeah, let's zero this bad boy out. Let's see if we have a 12.5 millimeter hole right here. Well, goddamn. All right, this thing is ready to tap. So that whole speech that I gave you about make sure to find the right drill bit, blah, 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 doesn't apply unless you're making your own tie rods out of tubing. So here we go. Okay, something that just happened as I was about to start tapping those tie rods for the M14 for the tie rod ends. I showed you guys this tap. It was the M14 by 1.5. I don't think you can read that there, but this is actually a helicoil tap. So helicoil is a threaded insert in case you stripped out a stud or something like that. You can put one of these things in here. I bought this kit years ago. Didn't even realize until I went to tap it, and this thing is monstrous compared to the actual M14 tap that I happen to have in this set here. So I had to root through all of my stuff and find it in here. So this helicoil one's going back in that pile, but we'll close up this 4,000 pound toolbox full of shit and get back to work. So I'm going to clean this tap up just a little bit. It's a little bit of rust on it. Just make sure, set myself up for success. All right. So I said I was going to clean this tap up, and I started to, and I realized maybe you guys might not know how to clean up a tap. So a little side note thing. This is called the thread file. So this one is made by a company called New Thread. This is a metric one. You can see, maybe we can get it to focus. There's 0.75. There's the 1.0. So I need the 1.5 side. And what these are is it's a file with the pitch already embedded in there. So here's the 1.5 here. So you find this one. We know we have a 1.5 thread on our tap. And if you have a strip nut or some buggered up threads or on a bolt, you might be able to save it. So you just run that in there. These teeth line up with the grooves of your bolt, and it just cleans it up, makes it look a little bit better. So just thought I'd share real quick. Okay, so I'm sure most of you have seen tap handles, tap wrenches, the tapping operation happening. But for those who haven't, I've got the tie rod clamped in a V block up against the vise. The reason I use the V block is that'll just lock everything in a little bit better than just the two separate jaws of the vise. Just gives you 3 points of holding instead of the two. It's just a little bit stronger way to do that to help prevent it from rotating. It might still rotate on me. As far as the tap goes, you can see there's a little cutting fluid on there. I'm going to try to start this on video for you. For those who don't do a lot of tapping operations, the key is to get it started and get it straight. So when you're looking at it, you want to try to make sure that it's in line this direction and this line as you're going, because you don't want to cross thread the tap. You know, there's a little bit of wiggle room, but for the most part, you're kind of committed once it gets started. So you can see down in there, those teeth on that thread that I repaired are doing their thing, but now we can watch, and the whole tie rod just started to rotate a little bit. There's a good little burr coming off of this. So when you're tapping, maybe a quarter turn at the most, and back it off a little bit. That breaks the little chip and helps not bind up the tap as you're going. But I did see it turn a little bit, so we tighten it up a little bit. Get about a quarter turn there. Go back just a scotch. Quarter turn, just back it off just a little bit. All right, this was going pretty well. And that's tapping 101. All right, let me get this all set up again, finish the operation, and bring you back. We are getting closer. Tie rods have been narrowed. Beam is currently outside baking in the sun, trying to get that paint dry, so there's not much to do in the meantime. Still not sure if I'm gonna put that steering dampener bracket on there or not. So if I do, I'll have to scuff the paint up and weld either this bracket or fabricate some kind of bracket, or I might even get fancy and make a clamp-on bracket. Don't know yet, but either way, I'm pretty close to getting ready to reassemble the beam. The fun part next will be narrowing the torsion bars. That sounds a little gnarly, but it's actually not that bad a job. So once I feel like getting greasy and dirty, we'll get going on that. When installing leaf packs, sometimes you'll think Satan himself came up with this design, because they will a lot of times kind of flare out when you're trying to reinstall them, because you got a stack of different torsions. So something I've learned over the years, take a zip tie, put it on super tight, and once you get it through that center block and you keep pushing it through, the zip tie will just slide down and live inside the beam for the rest of its life. Pro tip. Okay guys, we're getting real close here. Beam is now assembled with the trailing arms. You can see the torsion arms are sticking out there. We're going to chop those down a little bit. I think I got that steering box on right side up. If not, I'll flip it. It's just, everything's just mocked up. What we're going to talk about right now though is your camber on your trailing arms here for your front spindles. So this is the idiot book. It's not good for much, but it's got this really handy chart here for your shims that are in your king and link pins. So if you've got a 60 and earlier beam, you have hopefully 10 shims. If you've got 60 and later, then you would have 8 shims in your link pins. And here's what we're going to do. So we're going to measure the offset of these arms right here. There's the little illustration, and we'll do it in real time here. Okay. So the bottom one, you got to have yourself a nice straight edge here, like a good machinist straight edge. Don't use like a block of wood or something. This is critical to your whole handling situation. So right now looks like we're right at 8, maybe 9 millimeters offset. So we go back to the chart here. I've got 60 and earlier, so I've got 8, maybe 8.5 millimeters offset. I'm on the wide side of that table. So what I want to do is I'm going to go ahead and knock the lower arm in just a little bit, because I want to get ideally a 7 millimeter offset, because that gives me the widest range on my adjustment here. So grab a little hammer here. I'm just going to give it a light little tap, and let's see if I got any closer. call that 7mm and call it good. So now we're locked in on the driver's side trailing arms here, and we'll drill out the new dimples. Those are the old dimples right there. We're gonna drill out the new dimples and lock it into place. Okay, so we got the first hole drilled. I started at the bottom because that's the one that sticks out. And then once I drilled it, set it with a grub screw and made sure that my measurements are still on point. And I've still got exactly 7, so nothing shifted while I was drilling. As far as drill bits go, you're gonna need something halfway decent, at least high-speed steel, because we're drilling through spring steel and we're trying to make a divot that big. Now, the drill bit I'm using is, what size we got here? This is a 31/64. It's one size down from 1/2 inch, but if you get something pretty close, a 1/2 inch is too big, but anything, just a little bit smaller. It's going to sound counterintuitive, but what we're doing is we're using the existing hole as a pilot hole. Now, on a drill bit, the cutting surface is right there on the tip. The flutes on the side right there are not doing nearly as much cutting. So as long as you stay centered and you get yourself a dimple going, you're good. You'll feel it touching the sidewalls as you're drilling if you're off on the angle, a little too high, a little too low. So I get my little dimple started, and then I get a much smaller bit and I go to the depth that I want. Then I come back with the larger bit once again and set my finished hole size. That way I minimize the risk of hitting the threads inside the trailing arms. Even if you do nick them a little bit, there's still plenty of meat, but it's still good practice to try to avoid them as best you can. All right, so we've got the driver's side done now. Both of them are drilled out, grub screws are in, and we'll work on the passenger side here in just a second. I was lucky enough, my measurements still were at 7mm offset, so nothing shifted while I was drilling. If you do happen to be off a little bit, like let's say you got down to 5mm or 9mm or something where you were a little too offset, you set your grub screw again, and you might be able to tap on it here, and there might be enough lateral room on the upper or the lower adjuster where you can move it just a millimeter or so and try to get you back at 7mm or at least within spec. If that doesn't work, I would take the opposite arm, so the one that's on the passenger side, pop that off, throw it in here, and hope that maybe that hole is drilled just a little bit off and it will get you back into spec. But hopefully none of that occurs to you, but if it does, those are a couple workarounds. All right, hit 7mm offsets on both sides, which is dead center as far as spec goes. So that's, I'll call that luck more than skill. All I gotta do now is chop the ends of these torsions off with a cutoff wheel, and this beam is essentially done. I'm gonna take the arms off. I wanna recheck the needle bearings and everything, and make sure they're all back in position. I'll probably chop off the lower shock mounts too, just because I don't need them. I forgot to give you guys kind of a after shot of cutting the torsion bars, but that's what it looks like. I mean, you just cut them with a cutoff wheel on the angle grinder, and it's flush. And I didn't cut off that shock mount on this trailing arm, but I did get this one on this side, and this is all just together with stock components, all mocked up. Nothing's bolted together, nothing's measured. It's just on there just so I can see how it's going to go. because we still need drop spindles and we need disc brakes. But for all intents and purposes for this video, that's all you need to see. And this, friends, is a 6-inch narrowed beam with the first installation. Fucking massive tuck. Okay. Goal is achieved. This is without drop spindles or anything. So I'm right up on the headlight bucket and all that. But disc brakes and drop spindles are next, but I couldn't help myself. I had to get a look.